In this video, we're going to be talking about Newton's laws of tension dealing with objects that are being suspended. We're going to talk about basically a rope that is suspending a block that has a weight of 10 newtons. So the tension in this rope is equal to the weight. Since there's only the force of gravity pulling down and the tension in the string coming up, these two have to be equal. So if you had the same scenario and you had a little force scale here that was reading different levels of newtons, and then here's our 10 kilogram block, this would read 10 newtons as well. So the force scale would be equal to the weight due to the force of gravity. Let's say we have the same situation, but now there are two strings, both holding up a block that has a weight of 50 newtons. The total downward force is equal to the force of gravity. So the force of gravity is equal to the mass of the block and the acceleration due to gravity. If it has a weight of 50 newtons, its mass would only be 5 kilograms. So 5 kilograms times 10 meters per second squared equals 50 newtons. So 50 newtons is going down. The total tension going up also has to total 50 newtons. So since there are two strings now, each string would support 25 newtons. Makes sense, right? So the downward force equals the upward force. Well, now let's look at this situation when everything is not vertical, but we have these angles involved. So over here on one side, we have an angle of 25 degrees. And we'll refer to this as alpha. And on the other side, we have an angle of 65 degrees. And this is going to be beta. We're going to start setting up this problem just like we would previous time. And we'll give this a 100 Newton total downward force. So let's say I still have 100 newtons, but it's only suspended vertically by these two. Based upon we just talked about, each of these would hold 50 newtons, right? So if we go back and we look at this picture, this upward component would be equal to 50 newtons, and this upward component would also be equal to 50 newtons. What I'm really looking for is I'm trying to find the tension over here and the tension over here. So if I'm looking at my triangle, we'll do the beta first. So here's my triangle drawn out. I know this is 50, and I know this angle is 65, and I'm looking for the hypotenuse, which is equal to the value of tension in newtons. So here, I'm going to set it up. I have an angle. I'm looking for the opposite over the hypotenuse. So I'm going to use sine. I rearrange my equation to solve for the hypotenuse. Hypotenuse is equal to the value of the opposite divided by the sine of theta. When I plug in my values, I get 50 newtons divided by the sine of 65 degrees. I plug all that into my calculator, and I should get an answer of 55.16 newtons. That solves for beta. Likewise, over here I'm drawing a similar triangle. I have an angle of 25, and I know this side is equal to 50. Again, I want to solve for the hypotenuse, which is equal to tension. So I'm going to use sine again. Sine is equal to the opposite divided by the hypotenuse. Looking to solve, opposite divided by sine of theta. Now I just plug in the variables that I have. 50 newtons divided by the sine of 25 degrees gives me a total tension of 118.31 newtons. Now I check, do my answers make sense? Since this angle is much greater, it's going to have a much higher tension. Check. This is less, but it is still always has to be greater than the vertical component. So anytime I have a tension with any angle over here for anything, it has to be greater than that value of 50. So both of my checks turn out to be good. So I'm all set for this part of the lesson. All right, good job.